Good afternoon, everyone, and thank you for participating in HSBC's 5th annual China conference, making it such an exciting and successful event. My name is Wei, and I lead the effort for HSBC on the Hong Kong-China Autos Research from Hong Kong. I'll be the moderator for this next panel session. This afternoon, I'm excited, no, electrified, to host what I would consider, arguably, being a auto analyst, one of the most sexy and exciting panels this conference on an industry with global consumer interest and revolutionary implications, autonomous vehicles, anticipating the driverless era. This afternoon, we're privileged to have joining us Bruno Lambert, who is the CEO of Iconic Motors, as well as Xiaoshan Liu, who is the co-founder and chairman of Percepton. Just to give you a quick background on both, Bruno is CEO of Iconic Motors, which was founded by entrepreneur Alan Wu, together with Ralph Dubas, founder of supercar brand W Motors. The company expects its SPV to enter production in 2019 and counts as its partners W Motors, Microsoft, Magna and Studio Torino. Bruno joined Iconic in 2017, having supported the firm for 2 years, previously as Asia president of Magna. And over his 12-year tenure at Magna, he was involved in strategic projects with a variety of global OEMs, Chinese OEMs, and new entrants. As for Dr. Xiaoshan Liu, he is chairman and co-founder of Percepton. Dr. Liu has a PhD in computer engineering, and his research focuses on computer architecture, big data platforms, deep learning infrastructure, and robotics. He has over 8 years industry experience, where before founding Percepton, he was with Baidu, USA, where he led the autonomous driving system team. And prior to joining Baidu, he also worked on big data platforms at LinkedIn and has prior experience at Microsoft, Intel, and Broadcom. In terms of the panel format, I've asked both Xiaoshan and Bruno to prepare a 15-minute presentation on topics which I thought would have been of interest, then we'll open it up to Q&A. Xiaoshan will provide us with insights on where we are with autonomous vehicle technology, whereas I've asked Bruno to discuss how vehicle autonomy will change our commuting experience and habits as passengers of autonomous vehicles. With that, I'll pass it over to Xiaoshan to enlighten us on where we are with autonomous vehicle technology as of today.
Thank you, Wei. So yeah, autonomous driving definitely very hard today. Just as we speak, if you check out the tech news, this new round of fundraising for another startup spin-off from Baidu, they just raised $100 million as we speak. So it's definitely very hard. But I try to convince you that autonomous driving is not one technology, it's an integration of many pieces of technology. When you convert these technologies into a piece of product, there's a long way to go. Because it involves how you integrate this technology, it involves how to do the infrastructure and so on. I'm sure Bruno will share more story with you on that, but let's fly through the technologies involved in autonomous driving. So here, it's a very simple slide that I prepared that summarizes all the technology involved in autonomous driving. As you can see, there are 3 major parts, and then today when we talk to investment professionals, they're always concerned with one part, which is perception or sensing. How do you grab data from the environment to help you understand the environment? So that's the pink part over there on the very left side, you see sensing. When you hear stories like LiDAR versus camera, that's about sensing. Sensing is about how to get data from the environment. Then once you get data from the environment, the second part is how do you understand the data, and that's perception. It helps you to localize your car as you travel. It helps you to recognize the pedestrians and obstacles along the way. Once you get that, once you understand the environment, the last part, and then people rarely talk about, is how do you make decisions. Say if you see a pedestrian in front of you, should you stop the car or should you go around him? That's planning and control, and here we summarize it as decision. And then the blue part, not many people talk about, but that's the focus of NVIDIA and Intel, and that's the computing platform. You have so many different algorithms. How do you bind them, combine them together onto a computer that consumes a fixed amount of power and it's affordable to enable it to run on a car. So that's the blue part. As you can see, you have operating system, you have the hardware or the computing device. And that's why if you check out the stock price of NVIDIA, it's been rising in the past 2 years I think double or triple in the past 2 years, because they provide the best AI computing platform today. And then on the yellow part, and not many people talk about, is the cloud computing platform, because all the investment today, they all go into the client side, how do you enable a car, but not many people talk about the cloud. What do you need in the cloud for autonomous driving? For example, you need to create a map to help your car navigate around the environment. Who's the best? Google. Google has their Waymo HD map. And then you need to do model training and so on to enable better perception on the device. And then you need to do simulation. And then most importantly, you need to store the data, because autonomous vehicle, they generate 2 gigabytes of data per second. How do you store that? On Samsung, for example, they want to target the storage market. So there are many pieces here, there are many players here, which will convince you that it's not one technology we're talking about, it's integration of many pieces of technology. So to me, integration is the hardest part. So let's fly through these pieces. Localization, how do you localize your vehicle? Just like how if you drive your car around Hong Kong or around Shenzhen, you pull out your iPhone, there's GPS inside of it. That's how you localize yourself. But when you come to a car, the accuracy is much higher. So we use a very high end of GNSS device or very high end GPS device to help you localize your car. And then how much is that? Maybe $10,000 per piece. So that's already $10,000. And the second piece to help you localize, you need 2 pieces here. One is LiDAR, a very expensive sensor, the most reliable one being over $80,000 per piece. And then with a LiDAR alone, you cannot localize. You need a map. You need to recreate your map. You cannot use your Google map. You cannot use your Baidu map. You need to recreate your map to help you localize your vehicle. So that costs millions of dollars per city per year to build this map. So who's providing a map today? We're not sure yet. Maybe in China it's Baidu, in the US it's Google, in Europe it's here, but there's no winner yet. So that's for localization. And then the third way to localize your vehicle, say you have a GPS, but you need higher accuracy, is use computer vision. If you have a camera on your car, that can help you localize, just like human beings. When we travel, when we walk on the street, our eyes help us to localize where we are. So using computer vision is affordable, but there's a lot of arguments of whether it's reliable enough, whether it's enough to make the automotive grade. We will discuss that later. And then the second part that's very expensive is the client system. That's the first generation of computer system we built in Baidu USA, for example. 2 huge boxes. The cost of this computing platform, if we flip to these slides, it's about $30,000 per piece. If the computing part itself is $30,000, there's no way you can ship the car. So one technology challenge for these big companies, including Intel, NVIDIA in China, is Huawei, and so on, it's how to shrink the size of this computing platform, how to optimize this to make it shippable. So the best piece of computing equipment today we have is the NVIDIA PX series, but it still costs over $10,000 US. If you want to ship a car, for example, Bruno's company trying to ship a car, if you tell me the cost of the computing platform is $10,000 US, there's no way you can ship a car in massive amount. So affordability, that's what I want to talk about today. I personally believe that affordability decides whether you can ship your product or not. So if we examine the existing infrastructure for autonomous driving, we see for the LiDAR and sensors already cost over $100,000 US. And then the computing platform adds another $10,000, $20,000 US. The map, that's the crazy part. It's millions of dollars. Who's going to pay for that? Business model-wise, it's unclear who's going to pay for the map. So I want to save a few minutes to talk about how we see these things. Let's say my company is Perception. We are building affordable solutions for autonomous driving. How do we do it? We try to use computer vision. You can bind a few high-end cameras together into, say, a device like this, and it provides localization, helps your car to localize your vehicle in real time, and helps you to perceive the environment, and that's a very important part. If you see a person in front of you, you want the vehicle to recognize what's in front of you, how far away, the obstacles in front of you, and so on. And then the third part that people don't really talk about is that what if the car gets stuck? We need something called the parallel driving. That means a human in the background is taking over the car to drive the car around until it gets out of the stuck situation. So on the left, that's our car, $10,000 US total cost, including the chassis. On the right, it's a Waymo car, $500 US. So the Waymo car is designed for 40 miles per hour scenarios, what we call the level 4, level 5 scenarios, whereas our car is designed for 20 miles per hour. We start with low speed, but we make it affordable. You can think of it as, say, OFO or Mobike kind of story. Last mile transportation, but low speed, very cheap, $10,000 US, that's it. And then for localization, we did some experiments, but that's some details. If you travel, you have a very high-end GPS signal, $10,000 US, and then you have this computer vision device, less than $1,000. And then they match each other very well. That means the localization accuracy is really high if you use affordable technology, if you do it right. And then perception. So here is what comes from computer vision alone. You see a lot of cars on the top left corner, and then we use some technique called deep learning to extract the obstacles within the picture. And then that's the lower right picture you see. We can recognize the depth of the vehicles in the picture. And then we can tell you how far away the vehicle is from you, and then how wide, what's the size of the vehicle, such that you can make smart decisions to go around, or to go straight, or to stop. So that's very short. We went through the technology involved in autonomous driving. My personal take on this story is that it's still far away from a commercial landing if you use the traditional way, use the high-end lasers and so on. And then the major problem is that there are two obstacles we want to overcome in terms of technology. One is affordability. How do you make your solution affordable? The second one is reliability. If you have overcome these two obstacles, then we can see the light of commercialization. And then that's what Bruno is going to talk about. Thank you very much.
Yeah, why don't we pass the floor on to Bruno now,
right,
who can tell us how autonomous vehicles will change our driving or experience within an autonomous vehicle going forward. Thanks, Bruno.
Thank you, Shaoshan. So is that okay? You can hear me? Okay, so I don't really like the podium type of thing. So here, it's not only about autonomous driving. We get always confused now about what is really autonomous vehicle, autopilot, and that's a word which is misused more than used. Unfortunately for people like Shaoshan and I, then because we have to answer a lot of questions to our family and friends, what are you doing and why there are some accidents still going on. But the reality is that autonomous driving and driverless vehicles will come. But also, why do we need to wait to think about what the passengers will do in this type of vehicles? And that's more or less the essence of the creation of Iconic Motors, which is developing a purpose-built design for passengers, anticipating the driverless era. And I will not sell you cars. If you are interested, you can still contact me, but I will just explain you how this type of focus is representative of a big change in the automotive industry, which is opening up a new type of business model in terms of cost structure, revenue structure, and so on. So very often, and this is on the left, the picture of our first car, the iconic smart passenger vehicle, Model 7, which is looking a little bit like a minivan, but with a little bit more sexiness, I hope. And so far, we have got quite a lot of positive feedback on how impactful the design has been. And the reason why the design was impactful is also we are using the same design team who has been doing the sports car, which is next to it. And the sports car is a little brother of one car which was seen and showcased in the Fast and Furious 7 movie. Maybe some of you remember this car flying from the tower in Abu Dhabi, which is one of the mythical scenes of a Fast and Furious movie. And so those guys have been designing cars and trying to bring our brand to the right level of recognition. But ultimately, the way we see the future of mobility, because we always have this debate, what about the people who love to drive, that we have Iconic, who is able to deliver passenger-focused, fun-to-ride type of cars, and our partner, W Motors, who is able to develop driver-focused, fun-to-drive type of cars. This is today one of the biggest debates of our industry. How many people will continue to buy their own cars? How many people will continue to drive themselves in 10, 15, 20 years? And when we sit in China, now in Shenzhen or any big megalopolis, we know it's not really a pleasure to drive. When we go on holiday in California, then it's much more enjoyable to drive. So we will have a need to continue to drive for many of us who like to drive, but this is why we develop vehicles which are really made to drive and made to enjoy driving, like this type of sports car. And ultimately, cars are more made to move, and therefore the focus should be on what we do as a passenger. So we analyze this vision of what a passenger can do during the time of mobility. And obviously, this is linked to the mobility revolution, which is happening now. So this is a study we've made with some consulting partner on the evolution of the Ks, so connectivity, autonomous driving, shared mobility, and electrification in China. I will not go through the map in details, but there are mainly two milestones in this map. The first milestone is going to happen in less than 2 years. It's the introduction of 5G commercial networks together with new connected vehicle platform. And I mean new by latest generation of connected vehicle platform. Today, we are lucky enough in China to have already quite advanced type of connected vehicles with probably the leading vehicle in the world today is the Rowe RX-5, which was co-developed with Alibaba. And even the German car makers recognize that it is a leading connected vehicle in the world. But nevertheless, this type of car is still used by most people just having a little bit of Wi-Fi technology. And still people continue to use their phone. But when 5G networks and new connected vehicle platform like the one we are developing comes into play, then I guarantee you, you will not want to use your phone when you step into the car. And next is about robot taxi era, what Xiaoshan was describing, what people are talking every day at length. And obviously there are some technology leaders like Waymo and Perceptin and developing this type of concept tomorrow ready to be used in some test areas, like Waymo using already the suburbs of Phoenix to test some of their fleet vehicles. Nevertheless, it's a more complex story, so the real ramp-up of this type of technology and the real growth of robot taxi is more foreseen in the next 5 to 10 years. And again, I try to be vague because nobody has a crystal ball how fast infrastructure and regulations can be developed, and we can debate and answer your question afterwards. But China is at least one of the leading countries, if not the leading country, for this mobility revolution. So for a company like Iconic, what we do to make sure we are part of this mobility revolution, we are working on our new technologies. I will come back to this. The big advantage of a startup is that we have no legacy, so we can disrupt the revenue model, the cost structure, like I will show you in a minute. And more importantly, we need partners. So everybody who thinks that they can follow and succeed in this mobility revolution alone is just dreaming, because the complexity is so large that everybody needs real strong type of partnerships. And we are working together with Microsoft for our digital experience, which is supported by latest generation of AI assistant, which is able to interact with all the passengers in the car at the same time. We are also supported by Microsoft for autonomous driving roadmap. We are working with Magna, which is one of the lead automotive supplier and also complete vehicle engineering company. And also we have cooperation, for example, in the Middle East with Mazda City, which is one of the leading smart city model in the world today, and trying to see how autonomous driving vehicle will integrate the smart city environment. So more importantly than just talking about a car, as you are all mostly dealing with figures and finance every day, here it's about a new type of business model. When I started this project with this passenger focus, I never imagined that we would find out so many opportunities on exploring this new so-called purpose-built design. There was a study from Merrill Lynch, which was also relayed by McKinsey about 1 year ago, which you can see here. It's about how cars in the future will be designed with a certain purpose. Today, every car brand in the world is trying to address multiple types of customers. They are trying to sell a car for the guy who likes to drive in California. Then they are trying to sell the same car to one guy who is commuting to work every day in Germany. And then another car for a young generation, the same car, sorry, for the young generation in China. So the diversity of customers, because we are using global platforms, because the cost of development of those platforms requires high volume, the diversity of these cars and the type of customers is really conflicting. And that's why to move to a purpose-built design for a company with no legacy like Iconic Motors is possible. And we get few examples of cost benefits. So, for example, nobody really needs in Shenzhen downtown a car which can accelerate from 0 to 100 in less than 3 seconds, because you will never be able to even get close to that. And also, you will not need to have a top speed of more than 170, 180 kilometers per hour. It will never happen. And so we have a powertrain which is designed for urban use. This is not a small saving. I can guarantee you can bring a saving of $3,000 to $5,000 per car just by doing this. Then you have simplified driver area in the cockpit, which is focused on comfort and safety, not on giving fancy infotainment to the driver, because the driver in this model is supposed to drive. And then, again, a lot of our distribution model, and we are getting already a lot of leads and pre-orders, are fleet owners or ride-hailing companies. So this is, instead of having 5 or 10% of our cars being sold to large fleets, we can sell 80% of our cars to B2B customers. So obviously, different type of distribution models, different type of marketing approach as well. And last but not least, just as a joke, nobody wants to go into Didi or Uber and then see the driver removing his hand from the steering wheel just because he can. And this is the whole debate about introduction of autonomous driving today. Everybody is talking today about Autopilot or this type of features, which are to bring more comfort to daily commuters. But when you consider the impact of shared mobility, and when you design a car with the purpose of serving shared mobility, then you do not need level 3 or level 4 technology, because those are just comfort for the drivers. The drivers in this case is paid to drive. So those are also some cost savings, because the roadmap we focus on in terms of autonomous driving is directly level 5. So ultimately, we are able to deliver a long range, more than 400 kilometer, 7-seater premium EV for less than 1 RMB per kilometer full cost of usage without the driver. But we know this is, for example, one of the basic targets of all ride-hailing companies in China and around the world. So here, by combining a new business model, we can actually be much more affordable and competitive and disrupt this type of market. But it's not only about cost structure, it's about value proposal. And again, it's about the revenue model and using the fact that we have no legacy to disrupt this. So what we bring here is our new technology for remote diagnostic. So you are probably familiar with the over-the-air updates which have been made very popular by Tesla, but we are bringing this to the next level. We have a new type of electronics architecture with our cars, which is our own IP, which enabling us to diagnose through the cloud every single piece of electronics which you have in every car. And this is an individual diagnostic which we can do. So it removes any operation from relying on expensive hardware diagnostic tools or also operators. And we divide the costs of such operation of maintenance of electronics of the car, which will be, at the end of the day, the biggest issues you can have during the life of your car. Every one of us probably have experienced some type of electronics issues with our cars. And we divide the cost of maintenance by 30 times. 30 times. And why nobody else is doing it? Because everybody wants to charge you a lot of money for after-sales costs, because this is where most of the car makers have been making their money so far. We are a new brand. We do not need to make you feel the pain of having problems with the cars in a double time. So we can offer you a disruptive value proposal for after sales, less downtime, and much more value added. And this is thanks to new technologies. We know that other car brands, like Volkswagen, for example, are developing this technology for introduction in 2021. So we are in advance on this side, but at the same time, for a group like Volkswagen to introduce such technology will be very challenging, because they have to negotiate with all the dealers around the world to convince them that they need to charge much less money on after sales. And this is their biggest margin generator today. So again, the advantage of creating a startup in the new mobility revolution which we are living is this advantage of no legacy. And if we can move fast enough, we can actually disrupt part of the value proposal. But I get also the question then what type of revenues we can substitute with for this after-sales maintenance cost. So we are designing the car for the passengers, and our common goal with Microsoft is really to create a digital experience which will enable every passenger to have a personalized and immersive type of experience. What does that mean? You step into the car recognizes your face with facial recognition or recognizes your voice. You are welcome back. If you have been in any of our cars before, you can continue your movie from before. You get your list of favorite restaurants downloaded from the cloud. You get also your list of your agenda, your meetings, everything. You can continue to work in a smoothless manner. And this is not only for one passenger, because every passenger is recognized by the car sitting in a specific position, so the content is channeled to every passenger in a personalized manner. And this is not the future, this is already only next year. So this is something which enables, and we believe that everybody then will keep their phones in their pocket, because the car becomes 10 times, 20 times better than your phone. And this is what everybody is fighting today around the automotive industry. Why some of you or some of your customers from the large tech companies are investing billions into automotive today is because of the digital ecosystem which is surrounding the car. And that's the reason why there is really so much excitement. And the focus on the passenger is enabling us to channel more content. It's just a basic calculation. Our cars are being used by shared mobility companies, fleet owners, so the car is used longer time per day rather than purely a commuter driving to work. And then we have more passengers, and then our digital experience is enhanced to make sure that everybody will keep their phone in their pocket. So that's why we believe we can generate 20 times more revenues from digital content than in the standard car. And this is entertainment, e-commerce, advertising. The car will become the biggest captive window towards the internet. And we have to use this time in the right way. Today, nobody knows yet how to use it. I have seen a survey this morning showing that still people will spend maybe 25% of their time checking the road if they step into a driverless car. This is just a perception for some people who have never been into a driverless car. All of us have some fears, concerns, because we have never experienced this. Again, also, people don't know what to do in a driverless car anymore because it has never been existing, and the digital experience you have today is not to the level where it will be tomorrow. So this market is really a very large market once you connect the mobility to all the digital ecosystem surrounding it, and there is still a lot of opportunities to explore. That's what we are trying to do, to tap into this potential one step ahead of the others. And again, we are also developing our autonomous driving level 5 project, which is this car, which will be presented at the Dubai World Expo in 2020 with a demo fleet. And we are here focusing on this future of driverless era. But why wait for the driverless technology, which Xiaoshan explained before, to be fully ready until we to start focusing on the passenger? This is our call, that we want to start focusing on the passenger today and stand for being the only brand with the most advanced passenger experience. Thank you.
Great. Thank you for that very insightful speech, Bruno. Looks like we've got a lot more to look forward to in terms of our daily commute in the future. I'm just going to open up the floor to Q&A right now. I'm sure we're all probably quite familiar with the process now, but if not, we can actually ask questions in a digital forum. All we need to do is go to slido.com and enter the event password B102 in order to enter some questions, and I'll receive them up on the iPad here, hopefully. Maybe I'll just start with a question, and I think this one's probably both for the both of you, actually. The biggest question on everyone's mind is, when are autonomous vehicles coming? When can we get to sit in one on our daily commute to work? And where do you think the biggest hurdles in terms of regulation are? Which countries do you think are most ahead and doing the most in terms of development of autonomous vehicles? For this, maybe I'll just start with Xiaoshan, and then we'll pass it over to you, Bruno.
Sure, thank you. To me, I'm very pessimistic. I would say 5 to 10 years before we see the real commercialization of autonomous driving. In terms of which country is first, I think US. In terms of readiness, if you look at Waymo, they've been doing this for about 9, 10 years. But China, we just got started. If you say Baidu is the first one, it's been 3, 4 years already, but it's still a long way to go. And then if you look at the traffic conditions in China versus that in Phoenix, for example, where they conducted a test, it's more complicated, much more complicated in Asia. A lot more traffic here, so I think US would be the first.
Okay, great.
Yeah, we are working also in the Middle East on some test cities. So at the end of the day, the full deployment of robot taxi or driverless technology, which will touch millions of people one day, is for sure more 5 to 10 years away rather than tomorrow, like some people try to tell for attracting more money sometimes. But the key is anyway a step-by-step approach, and you need infrastructure regulation and technology and cost down and customer acceptance. All those factors come into play. Regulation and infrastructure can be deployed in area by area with different size of those areas. So that's why today already Waymo is deploying some test area in the suburbs of Phoenix. Then Mercedes is planning to do the same in Germany next year. So we are talking about dedicated areas, which will be equipped with the right infrastructure and where the regulation will be negotiated with the local municipalities to enable the right start and testing phase. This will be only a few hundred cars in the next few years, and then it will start to grow to a few thousand cars, and then to really reach the hundreds of thousands of cars and millions of cars which this technology has a potential to reach. It will take probably 10 years, but it will grow this type of sphere by sphere. And China has a potential for sure to be able to implement as part of their smart city development this type of areas as well as in the US. Maybe in China traffic conditions can be more complex, but if some cities decide that there is a radius of 5 kilometers in a specific area of a city which suddenly get close to any other traffic and then is dedicated to this, maybe in 3 to 4 years, then this can be planned and organized. This is a similar type of plan we see now in the Middle East, where some countries are trying to use their oil money to prepare for the modern cities of the future, and this is this is the type of plan they're having too.
But let me add to that. I think the answer is already in our slides. If you take Bruno's slides, he has a roadmap of how autonomous driving is going to pan out. And then he has a calculation, say 1 RMB per mile, right? That's the calculation for cost-wise. And then you go back to my slides, say what technology pieces are missing from there. You combine it two, you can kind of infer the roadmap for the real commercialization of autonomous vehicle. Sometimes maybe that's the roadmap, but the technology is not ready, and then maybe the cost down is not ready. Sometimes the other way around, maybe it's the regulation is not ready. But if you kind of combine the two slides, you kind of can infer the answers 5 to 10 years. I think we have a common understanding on this field, on these questions. Yeah.
Okay, great, thank you. There's a couple of questions coming through from the floor. The first one is for Bruno. Can you talk about your revenue model, upfront expensive, buying the car plus monthly subscriptions, or how would it work?
No, buying the car today, we get, for example, pre-orders from different fleet owners in China and in Middle East. Those are traditional fleet purchase, so you do not have any specificity here. We are developing our own leasing platform as well, because obviously to support this type of shared mobility model, you need to have a leasing approach. But ultimately, the big difference is not relying on the traditional 4S dealership, which have been especially declining in performance drastically in China. They are still maybe working in countries like North America with this traditional way of buying a car and testing it, but they are not working at all in China. So we see the need for more digitalization of the distribution as well. But again, leasing and digitalization are the keys.
Great, thank you. Another question from the floor. Each link in the value chain claims they will capture the majority of the value. Uber, Didi, OEMs, parts manufacturers like Conti. What are your thoughts on this? I guess this goes to both of you, so would you like to start on this one, Shashan?
Maybe let Bruno start with it.
Sure.
The value chain is very large, and again, it's not automotive industry anymore, it's digital mobility. So in a fast-growing business, there is a piece of cake for many actors, and the key is that none of those actors can claim to really cover the whole value chain. It's just too complex, and you cannot move fast enough. So I think the real success stories will come from the right partnerships and alliances. Today, you have obviously a lot of noise around electrification, but this might be falling down in less than 10 years once it's becoming more of a commodity, because the fast roadmap of battery technology will make electrification more of a commodity. But the key will be more on the digital and the user interface, which is being developed inside the car, and obviously around the self-driving technology, which is new for everybody, so everybody is trying to grab this business.
Well, to me, it's a disruptive field. We just had a very interesting conversation before we started this session, me and Bruno and Wei. So who are you taking on as a startup? For example, Bruno, he may be taking on Didi and Uber, and some other EV company are taking on Tesla. So you have a model to follow. So I'm taking on Tesla, and he's taking on Uber and Didi. So that's for the car manufacturer side. If you talk to GM, they are taking on Uber as well. They're doing a GM fleet of cars, autonomous vehicles, because mobility as a service is the new model. Then if you fall back, look at tier one. Traditionally, you have tier one supplier, tier two supplier, and tier one supplier will supply the full solution for car manufacturers. But today, this one is changing as well. We have a tier 0.5. For example, Microsoft. Can you call Microsoft a tier one supplier or tier two supplier? No, they're tier 0.5. They provide solution for entertainment, infotainment, for example, autonomous driving solution. But below that, you still have Conti. You still have some other guys. And if you talk to Huawei and some other companies, they are trying to become the first or the major tier one company in China as well. They say, hey, I can start with computing solutions. Then gradually, the computing solution would become the full solution. So it's really disruptive. You can say today we still follow the same value chain. That's the manufacturer, and then you have tier 1, tier 2. I think it's going to be disruptive, and you'll see a clear picture in the next few years.
Great, thanks for that. Yeah, I think it's actually a very exciting time that we're seeing all this disruptive technology coming out on the AV side, and kudos to both of your companies, both Perception as well as Iconic, in really thinking outside of the box and not just going down for the mainstream autonomous vehicle route. So I think that's definitely a very interesting question, and one which all investors would really want to know the answer to, where to put their money, right? One more question. Oh, wow, so many questions now. Okay, one more question from the floor is safety. Safety is a #1 priority for autonomous vehicles, and it's something which everyone focuses on. But at the same time, there's a lot of R&D, a lot of proprietary technology going into autonomous vehicles. Where do you guys see the balance between safety and sharing of this technology versus essentially capitalizing on it? Maybe Xiaoshan.
Sure. Yeah. If you look at the statistics, autonomous vehicle today is already safer compared to human drivers. If you look at statistics, per 1 million miles, human drivers will cause about 3 accidents. Today, it's about 1 for autonomous vehicles. If we can drop that to 0, that's the eventual goal. But in terms of sharing of technology, I think we need standards first. If you look at the standard side, when we test autonomous vehicle today, California is the leading state in the United States. The only standard we have is how many miles have you let the car drive itself before an interrupt. But they did not specify in what environment and under what situation, so it's not specific. So from the standard side, we are still very loose. We need more standards to ensure safety, then we can talk about technology sharing. But if the standard is not there, how can you judge this one is safer than that, right? So I think we need standards first.
Do you have anything to add to that, Bruno? Or?
I think anyways, the consensus is that even if there are still some accidents today, the benefits and the safety benefits of this technology will be very large. And so that's the statistics which Xiaoshan referred to. Unfortunately, there is no regulatory framework sometimes to handle some of the existing accidents. That's why they make the headlines. But the consensus is that still this is the path, and the problem is that obviously this type of technology requires also a long testing phase, and unfortunately maybe some companies are taking some shortcuts on the testing, and that's emphasizing the headlines and the concerns of the consumers. But I think the companies who are doing it well and not taking shortcuts are making sure that this technology will bring a safer world for all of us.
I think it's actually quite an interesting question. I mean, before just watching the AI section, we saw that, for a simple sentence, you can have gazillions of iterations. For something like autonomous driving, where you need to consider all the different variables on the road, then that becomes even more of an onerous task. One more question from the floor. What is the future traditional OEM when autonomous driving is widely adopted? Less cars needed in the autonomous driving society. Perhaps, Bruno, this one would be good for you.
I think, again, from my point of view, the perfect combination of self-driving technology goes together with shared mobility, because this is where real disruption can come. You have cars which are driving themselves 23 hours a day, potentially. And this is obviously a huge cost saving for mobility needs. Today you see a lot of traditional OEMs who are planning this future and understanding this future and talking about this revolution. So, and I'm sure some of them will make the right changes, and if they are big, and sometimes the changes are more difficult to make, but some of them are making them. A very good example is Mercedes Daimler Group, which has started this huge internal change program as well. And then you have some traditional players who are trying to resist maybe a little bit more this change and talking more about evolution or than revolution. For me, this was always a funny thing when I was sitting at, in my previous job at corporate level, especially in North America and Western Europe, when you have always a big debate, are we facing a revolution or evolution? When you look at the potential of autonomous driving together with shared mobility, the impact in terms of traffic congestion, overall city landscape, and time saving, cost saving for people. When you look at those benefits, which are all positives, and then it's much larger than what we called for the last 10 years a smartphone revolution, because the smartphone revolution at the end was putting a computer in your hand with a lot of practicality, but still quite expensive entry cost, which limited the growth curve at the beginning. And here, the cost will be cheaper for everybody. The convenience will be better for everybody. So if it's not enough to be called a revolution, when we have been using the word revolution for smartphone technology for the last 10 years, I think we are not having our eyes open. And that's a problem that some traditional players in the industry don't like to use the word revolution because then they get scared. But revolution is not a bad thing. We are not cutting heads. I'm French, so I know that revolution can carry a bad meaning, that heads are getting cut. Here we are only changing our business landscape and the value chain. And there is space for new companies to step in, because without legacy you can move faster. But there is also definitely space for old companies to succeed.
Well, to add to that, I think it's very interesting to think of what happened to the bike manufacturers after the bike sharing business. Right? You have OFO, you have Mobike. Then what happened to those guys? If you go back and take a look, then maybe that's a hint of what will happen when we have shared mobility.
Yeah, that's actually definitely transformed a lot of transportation modes within a lot of the Chinese cities, well, I guess around the world, to a lot of bike sharing. One question more for you, Xiaoshan, which is perhaps on the development and the technology side. Just from the hardware perspective, where do you think is the most lacking in terms of investment for autonomous vehicles to succeed going forward?
Well, a lot. If you look at the investment that's going into autonomous driving, most of the money actually went into perception, meaning how do you understand the world. But not much funding goes into, say, how to manufacture the chip to run these algorithms on. So the two leading companies, the biggest investor, Mobileye, right? That's from Intel. They bought Mobileye to integrate their solution into their chip business. For NVIDIA, that's another leading guy, but NVIDIA is saying GPU is good for everything. But there's no chip today that's specially designed for autonomous driving. It's more like these traditional players, they try to transform their existing business to fit autonomous driving. I think there's a huge opportunity over there. The second thing is storage. We talk to different storage vendors. They want to enter this business. They understand that if you are generating 2 gigabytes of data on the car per second, then there's a huge need for storage. But I don't see any funding going to storage. So because, of course, perception is eye-catching. I can show you a very nice graph of 3D environment. Then immediately you want to put money into this. But if I show you a chip, then you don't see anything, right? What's the purpose of that chip? It's very hard to invest to understand. But what I see today is the investment that went into autonomous driving is very unbalanced. The front gets all the money, the back, even the cloud does not get anything. And security, you mentioned safety. Security is closely tied to safety, but not much investment go into autonomous driving security. If you put out an autonomous vehicle today in Shenzhen, I have 20 ways to hack it without even touching the car. So that's why I said infrastructure is not ready yet for commercialization.
Okay. One more question, probably a follow-up on that, is just in regards to 5G technology. And this is really just for both of you, just in terms of 5G technology, how important do we see that to autonomous vehicle development, and perhaps maybe if you could elaborate on your own business models and how it's important to that. Xiaoshan.
Oh, sure. So we don't have 5G today, to be frank. 5G is a technology, but not a commercialization yet. It's very expensive to deploy 5G. It takes another 10 years for ubiquitous deployment of 5G in China. But even if you have 5G network today, it's not enough to run autonomous vehicle. It's enough to sustain one car on the street. But if all cars on the street are sending data, then the 5G tower will explode. So that's the story today. That's why I'm kind of pessimistic towards real commercialization of autonomous vehicle today or in the next 5 years, because how do you send the data up? You collect a lot of data. How do you send that up, right? Today, if you're Waymo, you send your car outside, do an experiment, you pull out 20 hard disks. And then when you come back, you manually pull out those 20 hard disks and upload data. But the infrastructure is really not ready. 5G is not enough. We're talking about 6G. Maybe 6G is enough, but 6G is 20 years out. Yeah.
So I guess, Percept, in terms of your technology, you would not really be relying on 5G for the development of your...
We cannot. Yeah. We cannot.
Understood. Bruno?
I think for me, it's less than for autonomous driving. It's anyways the connectivity flow which you can channel through the car. So that's why we are trying to see how our platform can enable the right level of usage of 5G technology. And it will take time to roll out, but Qualcomm anyway has announced that they will roll this out within the next 2 years. So it will progressively bring quite massive change. Especially, I mean, it's expensive in terms of infrastructure now, but the cost of data going forward will be really significantly reduced.
To echo on that, actually, Middle East is the good place to start with. If they are doing smart city experiments, then they are the governments willing to invest a huge amount of money into the communication infrastructure.
Given time, I think there's probably just one last question from the floor, and this is in regards to smart roads, whether we see that as being a critical technology in order for the development of autonomous vehicles.
As we said, anyway, the infrastructure is required, and Xiaoshan just said how we collect the data today. It's through V2I communication, so vehicle to infrastructure communication. That's at least for the next 10 years what will be the most relied on way to make sure you can introduce progressively autonomous driving vehicles. How heavy will be this infrastructure is still a debate, because it depends on the overall constraints of traffic and the regulation which will be imposed and so on. So I think you have different models. You have obviously the sensors which are already used in some highways around the world today, which is limited type of infrastructure. And then if you want to deploy really into this new smart city environment, the proper infrastructure, it will be very costly and will take time.
I agree, and there's no standard definition for smart city today. So I think that's, for today, smart road is still an experiment. Yeah.
Understood. Okay, well, I think we've gone through pretty much most of the questions from the floor, and given the time, I think we should probably just wrap it up here. So if everyone could just give a hand to Xiaoshan and Bruno. Thank you for joining us today.